Had your guide throughout this exciting journey into the world of automation and CI/CD using GitLab. Throughout this course, we will unlock the potential of GitLab CI/CD, a robust tool provided by GitLab. It's all about automating workflows seamlessly within your GitLab repository, enabling that smooth integration and continuous delivery you have been always aiming for. Our goal for this course is to get you familiar with the core concepts of GitLab CI/CD, its significance, and how it stands out from other tools. By the end of this journey, you will be well versed in GitLab CI/CD and its diverse features. We will kick things off by laying a strong foundation. We will dive into the absolute basics of CI/CD, exploring their purpose, benefits, and understanding the nuances between continuous deployment and continuous delivery. We will then dive deep into the core concepts, exploring the building blocks and components of CI/CD. So this is about GitLab CI/CD. So we will be starting from simple pipelines. We will gradually construct complex end-to-end pipelines covering unit testing, code coverage, containerization, deploying to Kubernetes clusters, and also uploading reports to S3 buckets. But that's not all. We will also explore other powerful features like jobs, reusable templates, self-managed runners, environments, secrets, auto DevOps, and much more. Now, here's the exciting part. In our learning structure, each topic will be presented in a 3-step format. First, a comprehensive lecture on the theory behind the topic. I will provide a thorough demonstration, walking you step by step through the practical execution. And finally, you will have the opportunity to dive in hands-on with our labs on CodeCloud. We know it is tough to access the right tech for learning. That's why we provide you with just-in-time access to the infrastructure you need to learn. An environment that's perfectly designed for you to practice what you just learned in the previous videos. Our browser-based hands-on labs open up right in your browser and help you go from watching a video to gaining hands-on practice within a few seconds. We don't just give you a set of steps to blindly follow. We give you challenges to solve. That way, you learn by actually doing it yourself instead of just watching someone else do it. With these labs, learning becomes not just informative, but interactive and practical. At CodeCloud, community matters. We got a vibrant forum where you can post questions, share your insights, or lend a hand to fellow learners. Join the CodeCloud community and be part of this learning ecosystem. If you're geared up and ready to embark on this exciting journey, I will see you in the course. Get set and let's explore the power of GitLab CI/CD together. Let's start the course by understanding the DevOps prerequisites of a software provider. Over the duration of this course, we will check into and learn about how GitLab CI/CD can be used to meet these DevOps requirements. Dasher Technology is a software provider which offers a platform to facilitate the connection of data, applications, and devices across on-premise environments for businesses. Recently, their research and development team has been exploring the possibilities of transitioning their services to the cloud and leveraging container technologies. Initially, they aim to apply this to one of their Node.js-based projects with intentions to extend this approach to other projects developed in Java and Python at a later stage. They introduced a DevOps team for this initiative, which is led by Alice, who will be responsible for establishing the DevOps pipeline for the project right from its inception, adhering to industry best practices. Their work will revolve around a multi-cloud infrastructure utilizing Docker for containerization and Kubernetes for container orchestration. Alice conducted a swift evaluation and learned that the current requirement penetrates to a Node.js-based project. The previous team operated without a version control system, which developers independently writing and manually integrating code. The testing process was sluggish and ineffective due to manual execution. Collaboration among developers was often hampered as they worked on separate code branches. With infrequent integrations and testing, software releases carried more significant risks. Deployment of software to various environments, including development, staging, and production, was primarily a manual procedure. To tackle these challenges, Alice and her team have opted to implement a continuous integration and a continuous deployment pipeline and have outlined the following key steps. First, they would like to adopt GitLab for version control and developer collaboration, and implementation of unit testing and code coverage measures to expedite testing and minimizing bugs, utilization of Docker builds and push processes for containerization, and the application is then basically deployed to Kubernetes clusters. And the pipeline should also be incorporated with various automated integration testing as a final step. The successful execution of these steps is expected to resolve the existing issues. Nevertheless, the team now faces the additional hurdles of selecting the most suitable CI/CD tool. In the market, a wide array of CI/CD tools are available, including Jenkins, Travis CI, Bamboo, Spinnaker, GitHub Actions, Circle CI, and more. After exploring several options, the team has made the decision to proceed with Jenkins as it stands out as one of the most extensively used open source CI/CD tools. To employ Jenkins, the team is required to undertake several tasks. One is to configuration and operation and upkeeping of virtual machines with specific CPU, memory, and hard disk capacity. And prior to Jenkins installation, prerequisites includes Java JDK installation, setting up firewall rules, and installing various different Jenkins plugins. And the last one, given this is, the project is centered around Node.js and NPM must also be installed. So to facilitate unit testing with various Node.js versions, the DevOps engineers must install multiple Node.js NPM versions, ensuring that the test runs without any version conflicts. And Docker installation is required for doing the containerization steps. Apart from that, for Kubernetes deployment, the installation of kubectl, Helm, or other necessary binaries is necessary. Teams often employ external tools for integration testing and reporting, which also requires the installation of these tools or their command line interfaces on the machine where Jenkins will be executed. It is important to note that these tasks apply to a single Node.js-based project with high-level steps. The pipeline's complexity may grow with additional steps, proportionally increasing the manual configuration workload. Furthermore, the organization intends to implement similar methodologies for other Java and Python projects running on cloud platforms like AWS and Azure. Depending on the specific project, additional software requirements such as Java, Maven, Python, Azure, AWS CLIs may be necessary. And if the pipeline demands enhanced security in line with DevSecOps practices, more tools like Privy, kubesec must also be configured on the same Jenkins instance. Considering that this DevOps team is recently established, many team members lack familiarity with a broad spectrum of tools and services, Alice has initiated a search for a tool that satisfies the following criteria: simplified setup and initiation without the need to install and configure numerous services, and a focus on building pipelines without the burden of managing infrastructure or concerns regarding scalability. Following a thorough evaluation of multiple tools, Alice has chosen to check and implement GitLab CI/CD. Over the course of this training program, we will check into the creation of GitLab CI/CD pipelines for a straightforward yet a real-time Node.js application. Thank you. Let's go ahead and explore the basics of CI/CD. In a typical project, source code resides in a Git repository where it's both stored and versioned. GitLab is a web-based platform centered around Git, serves as a centralized hub for hosting these repositories, and extends Git's capabilities with additional features. Typically, all code resides on the main or master branch, which is frequently deployed to production servers or environments. When there is a need to introduce new features or simply modify existing code, developers create and collaborate on what's known as a feature branch. This branch essentially functions as a clone of the main code base, enabling a team of developers to work on a new feature until it's fully developed. Once the necessary changes are made, the code is committed to the feature branch, and a pull request is initiated to merge this code back into the main branch. But before the merge takes place, a review process is carried out and the changes require approval from relevant team members or individuals. Following a successful merge into the main branch, the code is then deployed either manually or through an automated process to the production environment. This situation poses a significant risk to the application's stability, and as there are often no testing conducted on the newly merged code before it reaches the production environment. In real-time scenarios, you will often find multiple developers working on different feature branches, each focusing on a new enhancement. Performing multiple merges without the implementation of continuous integration in a software development workflow can lead to several significant problems and challenges such as delayed testing, inefficient deployment, and quality assurance challenges. Talking about delayed testing, without CI, testing typically occurs late in the development cycle, often after multiple mergers have taken place. This delay in testing can make it harder to identify and rectify issues early in the development process, which increases the risk of defects making their way into production. Talking about inefficient deployment, in the absence of CI, deploying code to various environments like dev, stage, production often relies on manual processes. This can lead to inconsistencies in deployment and potential configuration errors. And finally, without automated testing as an integral part of the development process, ensuring software quality becomes more reliant on manual testing, making it prone to human errors and subject to resource constraints. So now let's imagine a scenario where a developer 1 creates a feature branch A, makes some modifications, and commits the code to this branch. A pull request is generated to merge these changes into the main branch, but before the merge, a team member reviews the code and an automated CI pipeline is triggered. The CI pipeline proceeds through several stages, including unit testing, dependency scanning, artifact building, and vulnerability code scanning. All these assessments are performed on both the newly added code and the existing code from the main branch. If any of this test fails, the developer is asked to make the necessary adjustments and commit the changes to the same pull request. This action triggers the CI pipeline again, and if there are no failures this time, the pull request is approved and merged into the main branch. Upon merging into the main branch, the same CI pipeline, or possibly a different one with additional steps and tests, is automatically executed to verify the merged code. At this point, testing the same code again after merging may seem redundant, but I'll try to clarify this by the end of this video. So while these developments are taking place in feature branch A, developer 2 is progressing on a feature branch B. They commit the changes and create a pull request, and whenever the pull request is created, an automated CI pipeline is initiated, testing the code committed in this new feature branch B. So once the CI pipeline successfully completes, the pull request is approved and it can also be merged back to the main branch. So following the successful merge, the main branch now contains the code changes from both feature branch A and B. As mentioned earlier, any merges into the main branch should automatically trigger a CI pipeline. In this instance, it once again runs all the tests, including the unit test, dependency scanning, artifact building, and additional vulnerability scans. This ensures that the code changes from both feature branch A and B work seamlessly together. This entire process, which enables multiple developers to work on the same application while ensuring that these changes integrate smoothly without introducing any issues, is known as continuous integration. So far, we explored the concept of continuous integration. Now let's check into the CD part, which could be continuous delivery or continuous deployment. So in the previous instance, after a code integration is done into the main branch and successfully completion of the CI pipeline, manual deployment to the production environment was performed. In many scenarios, even after rigorous CI and testing procedures, it is advisable to deploy the modified application to a non-production environment that closely resembles the live environment. This allows for live testing before proceeding with production deployment. So within the same feature branch, following a successful continuous integration pipeline run, we can establish another continuous deployment pipeline. This pipeline should be responsible for deploying the modified code to either a staging or a development environment. So following deployment, a series of tests are executed to ensure that the quality of the application does not get degraded. Upon successful completion of CD, the pull request is approved and merged back into the main branch. So within the main branch, the CI pipeline is triggered assessing the newly merged changes. If successful, it automatically initiates the CD pipeline, which results in deployment of the application to the production environment. This automatic deployment process following successful continuous integration is often referred to as continuous deployment. In certain instances, a manual approval step before production deployment is a critical aspect of the deployment process. This step serves to minimize risks, ensure quality, adhere to compliance requirements, and effectively coordinate changes. It offers a safety net and allows for human judgment and oversight within an otherwise automated process. So in this scenario, following the successful completion of the CI pipeline, the CD pipeline awaits human approval before proceeding with the production deployment. This process of manual approval prior to production deployment is known as continuous delivery. Thank you. Let's assume an organization has decided to use GitLab as the code repository and is in search of an CI/CD automation solution. GitLab Server is an open source DevOps platform that allows you to manage your entire software development lifecycle from a single location. It provides features for version control, issue tracking, CI/CD pipelines, package registries, and many more. There are numerous tools available in the market to automate CI/CD pipelines. Nevertheless, given the organization's commitment to GitLab as the code repository or the version control system, let's explore how GitLab CI/CD offers the automation capabilities. So what is GitLab CI/CD? GitLab CI/CD is a built-in tool that helps you automate your software development lifecycle from code commit to deployment. It allows developers to automate tasks directly from their repositories. You can quickly create workflows or pipelines to implement a CI/CD job that builds, tests on every commit and also deploys merge request to any environment right beside your code base. So how are the CI/CD jobs executed? Runners are the agents that run your jobs. GitLab Runner works with GitLab CI/CD to run jobs in a pipeline. Out of the box, GitLab CI/CD offers two main options: software as a service SaaS runners and self-managed runners. In this session, we'll have a brief look at the SaaS runners, and later on, we'll also explore self-managed runners in a separate segment. SaaS runners are hosted and managed by GitLab. These runners fully integrate with gitlab.com server and are enabled by default for all projects with no configuration required. Your jobs can run on Linux runners, which supports a wide range of languages and tools. You can also choose Windows runners, which are ideal for projects that use Windows-specific tools or require testing on Windows systems. You can also make use of macOS runners, which is a good choice for project that requires macOS-specific tools and services. And finally, it also provides you GPU-enabled SaaS runners to accelerate heavy computing workloads for high-performance computing, such as the training or deployment of large language models as part of model ops workloads. Another advantage of SaaS runners is that GitLab manages the infrastructure for you, which includes setting up servers, scaling resources, and also managing the execution environment for your workflows. So your task is to write the workflow configuration, which is basically in YAML format, and GitLab CI/CD handles the rest of the stuff. This includes, executing your tasks within a newly provisioned virtual machine for each job, caching necessary dependencies, and also providing reports on the outcomes. Finally, the automation helps to streamline development by releasing new features and bug fixes to your users more quickly. It can also automate your deployment so you can reduce manual errors. And finally, it can increase the efficiency of your software by catching bugs early and often before they make it to the production environment. So how does this work? So let's just check out the YAML file which is used for creating and running these pipeline jobs. So to kickstart, you will be starting with a .gitlab-ci.yaml file in your project's root directory, which contains the configuration for your CI/CD pipeline. And a pipeline is nothing but an automated process capable of executing one or more jobs. These pipeline jobs this basically run in response to specific events occurring in your repository. For instance, in this example, a simple event like committing code to the main branch of the repository is going to trigger the pipeline. And within the pipeline, you can define one or more jobs. Jobs defines what you want to do. For example, you want to test whatever code changes which you're committing, or you want to deploy, the code changes to a different environment. And a runner is a virtual machine that is responsible for running your pipeline jobs upon triggering. GitLab, as we discussed, automatically provisions SaaS runners for each job based on the tag specified. In this example, there is a job named as unit test job that runs on 3 different machines: Windows, Ubuntu, and macOS. And consequently, GitLab will provision these 3 virtual machines for these jobs. And these virtual machines are known as GitLab hosted SaaS runners. In this particular example, all the runners are provisioned and operated in parallel, and you can also change the behavior if required. So once the runners spin up, by default, GitLab runner performs a clone of the repository to fetch the latest commits. After cloning, the runners start the execution of the steps or commands which are defined within the script of the YAML file. So in this example workflow, there are 2 commands and they are executed sequentially. First, it's going to run the npm install command, and it's going to install the Node.js packages on the runner machines. And then it's going to run the npm test command to execute the defined unit test cases. These same steps are executed on all the three runners concurrently. And consequently, if one of the runner completes all the steps execution, it will be marked as successful, even if the other runners are still in progress of executing their remaining steps. The pipeline as a whole is marked as successful only once all the three runners have completed their task successfully. So during and after the job execution, if you want to access the logs, the outputs, or any artifacts for each job, you can access them via the GitLab user interface, or you can also use the GitLab REST API. So this information is basically received by GitLab from the runners where the jobs gets executed. So within the GitLab repository, you can simply navigate to the pipeline tab to inspect the pipeline status, the logs, and the artifacts. And once you go to this page, you will be finding that there is a job named as unit test. It has been executed on 3 different machines, and you can view the logs of each of them individually. This is going to allow you for detailed debugging of the workflow's progress and its results. And if the job generates any artifacts, you can access and download them as well. So GitLab provides a very convenient interface for managing and retrieving any artifacts produced during this workflow execution, and therefore enhancing the overall visibility and usability of your automated processes. So finally, in this video, I have provided a brief overview of pipelines, jobs, scripts, and runners. So these concepts will be explored in greater detail in our upcoming sessions. Thank you. Let's start by exploring the GitLab account. I'm making use of the In this session, we will explore the core concepts of a GitLab CI/CD pipeline. It consists of 4 key components: pipeline, stages, jobs, and script. So let's take an example to understand them. A pipeline is an automated process capable of executing one or more jobs. It's going to act as the blueprint for continuous integration and deployment. It's going to ensure that the code changes flow smoothly through testing, building, and the deployment phases. The pipeline is defined using a YAML file, and it is located within your repository right beside your code base. To uniquely identify different pipelines, each pipeline can have an optional workflow named keyword. So this name will be visible in the Pipelines tab of the GitLab repository. Pipelines are triggered by events such as code pushes, merge requests, or manual actions. In this example, the rules keyword within the workflow is going to trigger the pipeline when there is a commit to the main branch. We will talk more about triggers and rules in a later session. The next core component is a job. Jobs are the building blocks of the pipelines, and you can have one or more jobs within the same pipeline. Each job is associated with a runner. It could be a GitLab hosted or a self-hosted runner. These runners are basically virtual machines which are responsible for running the job's instructions. We can optionally define a tags keyword to specify the runner, and in this example, the job 1 will run on a Linux machine. And if there is no tag keyword within your job, the jobs will run on a default runner. So we will talk more about tags, runners, and the runner configurations in a later session. So the core component of a job is called as a script. So the script contains the commands which needs to be executed. It is like the heart of the pipeline, defining the specific tasks which have to be performed. So scripts can be written as individual commands, as a shell script, or other supported languages. It's going to offer flexibility in different automation tools. So all the steps or commands within a script are executed sequentially. And typically, scripts includes, commands which are used for building code, running tests, deploying artifacts, performing security scans, and also in some cases, generating documentation. And each job can also have a before and or after scripts. So these are optional scripts that run before or after the main script of a job, providing opportunities for setup and tear down activities. So the common use cases of the before script is to install the dependencies, preparing test environment, or setting up some database connections. And some common use cases of the after script includes cleaning up the resources after a pipeline execution is completed. And if a pipeline has multiple jobs, by default, all the jobs are going to be executed in parallel at the same time. So to logically group jobs within a pipeline, we use a concept of stages. So stages provide logical grouping of jobs within a pipeline. They represent distinct phases of the CI/CD process, often aligned with the development milestones. So stages execute jobs in a predetermined order, thereby enabling conditional execution, allowing flexibility based on outcomes of the previous stages, optimizing resource usage, and also preventing unnecessary actions. So the common stages includes building, such as compiling the code, testing, running automated tests, deploying the code from one environment to another environment, and finally, scanning for vulnerabilities using the security stage. In this example, we have defined two stages, test and deploy, and hence the deploy job will start execution only after the unit test job successfully completes its execution. And talking about pipelines, in GitLab CI/CD, it offers a wide range of pipelines, and it has different configurations which can be used to tailor your software delivery process. So we have the basic pipeline, which executes the jobs within a stage concurrently, moving to the next stage only after all the jobs the current stage are completed. We have DAG pipelines, which can optimize efficiency by running jobs based on dependencies, potentially reducing execution time compared to basic pipelines. We have merge request pipelines, which trigger specifically for merge request, ensuring code quality and consistency before merging branches. We have something similar called as merged request pipeline, which simulates the merge state of a merge request, providing early insights into potential conflicts or issues. Then we have merge train pipelines, which queues the merge request for sequential execution, ensuring a controlled and orderly integration process. We have parent-child pipelines, which are used for managing the complexity by breaking down extensive pipelines into a parent pipeline that orchestrates multiple child pipelines, often used in a monorepo environments. And finally, we have the multi-project pipelines, which can coordinate pipelines across different projects, fostering collaboration and streamlining cross-project dependencies. So we can choose the pipeline that best suits your workflow, team structure, and project needs to achieve efficient and reliable software delivery. Thank you. Let's go ahead and create our very first pipeline. So before creating a pipeline, I would like to go ahead and create a new group. So let me create a new group. I'm going to name this group as demos group, and all my demos within this course will be part of this group. Okay. And if you see the group URL, it's going to be gitlab.com because I'm using the SaaS subscription / the name of the group. and I'm going to make this a public group. Okay, and I'm going to leave the rest of the options as it is with the default options and create the group. So within this group, I'm going to go ahead and create a new project. I'm going to name this project as a Hello World. So let me just name this as Hello World. So this is going to be your endpoint. So if you see here, this project or this repository will be part of the demos group, right? So I can also, select the group to which this project has to be associated with. So let's select the demos group, and we'll just go with the default settings. The only change which I want to do is, I would like this, project to be a public project. And I also want to, initialize the repository with a README file. So let's create this project. Okay, so this is a very basic project. It only has one README file, and if you scroll down, it's just going to show you some, getting started, README documentation, which is, auto-populated with, all GitLab projects. Okay, and how do we create a pipeline, right? So if you, just check out the UI on the right side, it gives you various suggestions like adding a license, adding Kubernetes cluster, setting up CI/CD, configuring integrations, and other things. So let's click on Setup CI/CD. So it's going to take you to the build phase. So if you see on the left side within the project, you have a lot of options like managing the members, activities, planning the issues, the code repository, basically the branches, repositories, commits, tags, and everything, and the build. So within the build, we have pipelines, jobs, pipeline editor, and a few other options. And apart from this, you also have some security, deployment, monitoring, analyzing, and settings available for this project. So we will be exploring a few of these features as we move forward in this training. But as of now, when I want to set up the CI/CD pipeline, it brings me to the pipeline editor page. So here, if I click on this configure pipeline, it's going to go ahead and create a new gitlab-ci.yaml file. And this is a hidden file. So this is basically created at the root of the repository. So this is the file which contains your entire CI/CD pipeline configuration, right? So before I configure this, let me click on the pipelines under the build section. So it's going to, show you out of the box, it has a lot of pre-built templates available for different projects. So if you're working with an Android project, or if you're working with some, Go, Gradle, .NET project, so you could directly use the pre-built template, just make some modifications, and start using it as a full-fledged CI/CD pipeline. But the thing with this pre-built templates is, in order to use them, or in order to configure them, you still need to know the basics or the terminology of GitLab CI/CD. So before I use these templates, we'll explore the concepts, and at the end of the course, we'll be having a section totally dedicated on using the pre-built templates, right? So let me just skip this, go back to the pipeline editor, and configure a pipeline manually. So here, as you can see, it's going to again give you a sample Hello World pipeline, right? So I can, simply clean this pipeline. And at the same time, it also, gives you some options for browsing the templates or the CI/CD catalog. So we'll be, exploring them in a, separate sessions. So what do you write in this configuration? So the first part is jobs. So any pipeline configuration begins with jobs. So jobs are the most fundamental element of a GitLab CI YAML file. So let us first define a job. So you can give it any name. So I'm just going to name this as first job. And within the job, again, you can give a lot of configurations. As of now, if you see, if I don't give any configurations, at the top, it's giving me a warning saying that this configuration is invalid because it needs a script or a trigger keyword. So we'll go ahead and define a script. So what is a script? So scripts are basically used for specifying commands for the runner or the virtual machine to be executed. So this is basically your pipeline code, what you want to execute. So since this is a very first pipeline, I'm just going to keep this as simple as possible. So I'm just going to use some echo commands and some listing commands. So I'm just going to type some message over here. And I'm also going to use some Linux commands like listing the files. And if you remember, we also have a README file. So let me just get the entire file using the cat command. Right? So this is our very first job. It only has a single script with 3 commands. So let's commit this and see how the pipeline gets triggered, and we'll also check out the logs as well. So let me just scroll down. You can give some commit message. You can also mention to which branch you want to commit this changes to. So let me just push the changes to the main branch with the default commit message. So once committed, you can go to the repository. You can go to core repositories. You can see that a new file has been committed and a pipeline is also triggered. So you can check the pipeline details over here, which is currently in the running stage, or you can go to build and you can click on pipelines. So our very first pipeline is currently in the running state. So let me just quickly go through the UI. So it's going to show you the status of the pipeline. It's going to show you the commit message, the pipeline ID, the branch on which it was triggered, and the commit ID. It's also going to show you like who created this pipeline and what are the stages. So we'll talk about stages at a later point. It is a core concept of GitLab CI/CD. So currently it says that the pipeline status is passed. So let's click on this and see what has passed. So it brings you to a different UI page where it's going to show you your actual pipeline. So each pipeline has various stages. If you don't define any stage, by default, it is going to use the test stage. We'll talk more about stages in the next session. And here you have your job. So this is the name of the job which I mentioned. So this is first job. So let me just click on this and see what does it show. So it's going to show you the entire log of your job, right? So let me just minimize the steps and explain them individually. So first, if you see here, it's saying that the job was started 1 minute ago and it is passed. And let's see the logs. So here it's saying that this job is running with a GitLab runner. It's giving you the version of the runner, and it also gives you the operating system which was used for running this job, right? So it's saying that it is used a Linux virtual machine of size small, and this is the name of the runner. So if you don't define any runner, by default, it's going to make use of the GitLab shared runners, and it's going to use one of the available runner. And if you don't define a runner, it's going to by default use a runner of size small. And within this runner or within this virtual machine, it also requires an executor in order to execute or run your script commands. So the first step is it's going to prepare the executor. And as you can see here, it is using a Docker machine executor. And in this executor, it's making use of a Ruby container image. So it's going to create a container based on this image, and within that container, it's going to execute your job. So if you see the next one is about preparing the environment. So it's running your job within this executor. So first, it's going to get the source code from your Git repository. It's basically like checking out your code repository to this specific runner, and you can say that it is just pulling the latest commit, right? So this is the commit ID, which you can see on the right side as well, right? So once the commit or the repository code base is checked out, the next step is executing the step script. So whatever commands you defined in the script phase will be executed here. And again, it's saying that all these commands are executed within the same container which was created earlier. So here it's going to show you the command and the output of the command as well. So first we used echo command. It's going to show you the echo. Then we used the list command. So when we committed this, it only had one readme.md file, but it cannot show you the gitlabci YAML file because that is a hidden file, right? So that's the reason it's not visible over here. And then I used cat readme.md. So it's just going to print out the entire readme.md content. And finally, after it completes all the scripts and the commands, if there are no errors, it's simply just going to clean up the project directory and the job gets succeeded, right? So that is how you can create a basic pipeline and run it without any additional configuration, right? So again, the same details can be seen on the right side, like the name of the runner or the type of the runner which is used. It gives you the pipeline's unique ID. It shows you the branch details. It shows you the duration, like how much time it took to complete this, pipeline execution. So that's all for now. So the next sessions, we'll talk more about the core components like the runners, the executors, and the types of runners. Thank you. Building on our previous demo of pipeline definition and execution, we will now focus on the key components of GitLab CI/CD. So the three components of the GitLab CI/CD are GitLab Server, Runner, and Executor. In this session, we'll discuss about the runner. So these runners are external machines or virtual machines responsible for executing pipeline jobs. They register with the GitLab server to receive and process job instructions. You have two main options, shared runners and the self-managed runner. Each has its own set of advantages and disadvantages, so choosing the right one for your needs is important. So talking about the shared runners, so these are the runners which are provided and managed by GitLab. They are available to all projects on a GitLab SaaS instance and are used on a first-come, first-served basis. So talking about the pros, so the shared runners are, easy to use because you don't need to set up or, do any kind of maintenance. You just start using them. And it's also cost effective because it's included in your GitLab subscription and some of your tiers. And finally, it's also scalable as GitLab automatically scales the number of runners to meet the demands. Whereas the self-managed runners are the runners that you install and manage yourself on your own infrastructure. And even this have some, advantages like, you have the complete control over the runner configuration, environment, and security. And performance-wise, these runners can be faster and more reliable than the shared runners. And since these runners are isolated from other projects, potentially it's going to reduce the security risks. And we also need to know the challenges. So challenges of the shared runner includes, limited control, where you don't have the control over the runner's configuration or the environment where it runs. The jobs may also, be slower due to the competition for resources. And finally, the runner shares resources with other projects, potentially, introducing security risks. And talking about the self-managed runner, It is complex to set up and maintain, as this requires technical expertise to install, configure, and maintain the runners, additional to, creating the pipelines. And, this can be difficult to scale as your needs grow. And finally, you may require additional hardware and software cost to, just keep them up and running. Thank you. In the last session, we talked about GitLab CI/CD runners, which are essentially workers which execute your pipeline jobs. So what are executors? Why do we need them? So runners themselves don't directly run the jobs. They utilize something called as an executor to actually carry out the execution based on the specific needs of your project. And under the hood of each runner lies a hidden engine called as an executor. So what are these GitLab runner executors? So you can think of an executor as a container within your runner. You can define the operating system, tools, and the resources a job has to access. And they ensure that the jobs run in a consistent and isolated environment. It's going to prevent conflicts and any unexpected behavior. So GitLab offers a wide variety of built-in executors, each with its own pros and cons. So choosing the right executor is crucial for ensuring efficient, secure, and reliable pipeline execution. There are around 10 different types of GitLab runner executors. So let's have a look at some of the most widely used executors. So let's start with the shell executor. So this is a very basic executor which runs jobs directly on the runner's operating system using its shell like Bash or PowerShell. It is very simple and lightweight. It's also suitable for quick scripts or for testing basic functionality. And it has some disadvantages like it's going to share the runner's operating system and resources. So it's going to always have a risk of conflicting and unexpected behavior. And the results may also vary depending on the runner's environment and the installed tools. And finally, sharing the resources might pose security risks if the job requires different levels of access. The next executor we'll discuss is the Docker executor. So for greater isolation and reproducibility, Docker executors run jobs inside a Docker container. These containers encapsulate the specific environments like the operating system, libraries, tools needed for the job, guaranteeing consistent across multiple machines. We can also choose from the countless pre-built Docker images with specific tools and environments which are readily available. And of course, disadvantages are, it requires additional configuration and understanding of Docker concepts. You also need to run multiple containers and it can consume more system resources on the runner. And finally, the Docker containers often have restricted access to the runner's native resources. And the third type of executor is a Kubernetes executor. If your project utilizes Kubernetes cluster, the Kubernetes executor lets you seamlessly run jobs as pods within those clusters. This is going to leverage the cluster's resource management and scaling capabilities for efficient execution and parallel processing. And of course, talking about the disadvantages, it's going to have a very complex setup and requires, complex maintenance, because you need to have familiarity with Kubernetes configuration and management in order to, manage the executor within a pod. And then it may not be feasible, if you don't have a Kubernetes cluster. So there is a potential dependency on existing infrastructure. And finally, it's going to have an increased learning curve because you need to first understand the best practices and security considerations for running the jobs within Kubernetes. The fourth type of executor is a virtual machine. So if you need a completely clean slate for each job, the VM executor is going to create a new virtual machine for each job execution, guaranteeing isolation and eliminating potential contamination from previous ones. And of course, it has its own disadvantages. One is it's going to have a very high resource usage because VMs require significant disk space, memory, and CPU resources, potentially, increasing your infrastructure cost. And it's also going to have slower startup times because creating and initializing VMs takes longer than starting containers, slowing down pipeline executions. And finally, it also requires expertise in VM management and configuration. The fifth type of executor which we will discuss is the SSH executor. This executor is going to allow running jobs remotely on another machine via SSH connections. It is going to be useful for utilizing specific resources available on a different machine or integrating with pre-existing infrastructure. Talking about the challenges or disadvantages, it always has security concerns because it requires secure SSH access and careful configurations to maintain jobs and system security. It also relies on a reliable network connectivity between the runner and the remote machine. And finally, it has limited control and visibility because managing and monitoring jobs running on a remote machine might be more challenging. And finally, the last type of executor which we will discuss today is the custom executor. So GitLab offers additional specialized executors like parallels, Docker machine, and even some custom ones which you can develop yourself. So each is going to cater to a specific need and environments, ensuring flexibility and catering to the diverse workflows. And talking about the disadvantages, it's also going to have overhead and complexity because you have to create your own executor and start using it. So you need to know how to develop it. And it's going to also increase the resource usage. And the third one is it's going to have limited access to the underlying systems. So these executors support different platforms and methodologies for building a project. So this is an official table which shows the key facts for each executor, which will help you to decide which one to use. And I would also recommend you to check out the official documentation for more information.